Well, my name is Ulrik Jørgensen. I'm going to present a paper that discusses the achievements we've made in DTU education and design and innovation, and compare these to the CDIO standards and the CDIO syllabus, the CDIO principles. And, well, this is... does this work or does it not work?
It works.
It works. So, fine. Okay, just a little in background. It's a critical comparison. The Design Innovation Program was established as a full bachelor's and master's program already in 2000, so it's a little earlier than the communication of the CDIO principles, so of course some of these were already experimented with in several places at that time, so it's in a way independent of CDIO, and therefore I wanted to make this take this more comparative approach together with my co-authors, Han Lindegaard and Søs Brodersen from the Department of Management Engineering at this university. We built on the experiences from project-based learning experiences, and the teaching of engineering and product design, and also from the experiences from teaching innovation and technology studies to engineers. And therefore the kind of discussion I'm going to take is not just about form, it's not just about pedagogical form and organization, it's also about content and content aspects. Within that strict time limit we have here. I would just start out and say one of the things that was crucial to creating this program was to build a strong informal team of teachers. I think this cannot be stated enough and too few times. The cooperation between the different disciplines goes through the personal communication and the personal commitment of the people teaching these disciplines. If that part doesn't work out, it's very difficult to create integrated programs. So the challenges we saw more in general were that the kind of science orientation, which has been prevalent very much at this university too since World War II, in a way delivered some achievements, but also seemed to have some limitations concerning the, well, production aspect, or the, you could also say in the CDIO terminology, operational aspects of engineering, and concerning the creativity and the design aspects. This was taken up during the 80s, some places even a little earlier, but at least late 80s, early 90s, many universities started discussing why does this science orientation not provide a strong emphasis of what should be seen as core in engineering, namely the outreach aspect of doing things, of creating things, of building things. There seemed to be kind of an analytical focus that has slightly or more dramatically transferred engineering teaching from being activities in lab and construction sites, construction labs, test facilities, into textbook teaching and simulations. So this tendency seemed to be part of that science orientation, and of course there's been lots of discussion about this and lots of activities, but I think these are some of the challenges that we are meeting, and you could take from the US debate, for instance, but also from the European debate, more prevalent though in the US, the question of production matters, and more broadly this discussion on creativity and design. So we see the number of design programs in different forms surfacing throughout the last decade of the 20th century and the first decade of this century. I see CIO partly reflecting that kind of change, or that new perspective on reforming engineering education. It relates to a new role of technology in society that expands, open for new demands, but also for the demand for new engineering competences relating to sustainability and climate issues, for the time being, of course, very prominent, but a broader use of the complex technologies in everyday life and in all facets of even professional life, and the pervasiveness of new technologies. These facets are things that challenge the kind of classic engineering programs with an emphasis on analysis and calculus. So what we did with the Design Innovation Program here at the university is we have what we would call 3 content pillars and 3 structural pillars that are really foundational for the program. The content pillars are engineering design synthesis, the analytics from social material studies, and the reflexive technological knowledge. And there's some kind of intention with the wording. You will also find them in slightly different way, but in the paper. The intention is to focus on the purpose of these activities. So it's not just about technical knowledge. I'll return to that when I'll discuss what Ed says about CDIO and the challenges from CDIO. But I just want to emphasize it here. So it gives us not only a set of disciplines, it also a kind of tendency in the focus that you should be taken within these disciplines to supply a complete program. The 3 structural pillars are project assignments, are the core structure of the whole program, almost projects every semester. Semester coordination of topics and disciplines is crucial, so the students have an aligned kind of set of courses and projects to work on, and then the progression in topics and depths that has to be kind of developed quite carefully. And to be honest, my own experience from working decades at this university and having quite some knowledge about other universities, this question of constructing the interactive part of an education program, not just the courses, seem to be quite a difficult task in most places because courses and even projects are owned by departments, are owned by disciplines, and therefore this team building part is so crucial. So what is important on the educational learning side of this is that in our view, engineering competences include a number of things that kind of go beyond what you could say is the knowledge part of the textbook-based type learning or the computer-based type simulation activities, the calculus and the analysis that relates to this. It's domain insight in the field you're going to work in. It's the ability to learn and investigate. It's the understanding of heuristics and the importance of heuristics. This is a topic that in most cases are not taught explicitly. And then the experiences with using knowledge in teams. So it's not just about teamwork, it's not just about communication, it's about a specific form of knowledge application within teamwork. And that relationship becomes crucial. If you read, for instance, the Abbott criteria and other places, many of these things seem to separate communication skills, teamworking skills from the domain knowledge and the specific type of disciplines at play. So these skills seem to be general. Everyone needs that. If you study theater, if you study literature, you need the same skills. Are they really the same skills? That's a big question here. I don't think so. I think this integration is important. And that again raises this kind of challenge that we have seen in creating this program, that the technical disciplines are often taught as correct and instrumental answers to model problems. I know that in many conceptions, the individual teachers, the engineers, they see this as applied kind of science on real problems. I would say we need some kind of self-insight here. It is mostly model problem, instrumental answers to model problems that are taught. So what does it mean? These are not irrelevant, but we have to contextualize them. So contextualization is not just about things from the outside, meeting society's need in a heroic way. It's really also a problem of how disciplines are approached. So learning is much more than applying theory. The achievement in our program has been that an internal evaluation has demonstrated good uptake in society, variety of jobs for our candidates, the importance of bringing design to production, so meeting the practical needs also of production. We have looked into the statistics, of course, at the university of the performance of the study program. This is one of the most gender-balanced study programs. There's a high throughput, and just a little remark on that. We never focused on a specific type of recruitment of women That was not our focus, we just changed the program content. This is one of the very challenging things in this discussion about, oh, why don't we have more women in engineering or in IT? Well, so you start recruiting strategies. It's very much about the content. I would say students are much more clever than you think. So they know what they need afterwards, so you can't just make advertisements. You need to do serious changes. So, and then we have been through an accreditation. The Danish kind of government has an accreditation program with, well, as many governments nowadays have, and it's very positive comments we got, and they pointed to the importance of the studios, which just makes me make a little remark that this reframing of the teaching environment is a crucial part also of reforming engineering education. So this format is not what we want to support in general. We do teaching like these kind of presentations like this one, but most of it will be organized in very different formats, and that establishes demand for studios. I think one of the problems with the, now I go for the critical discussion in comparison with CDIO, I think there are some paths, or to be more kind of critical, past dependencies involved in the CDIO program. Principles. There are some hidden assumptions about natural and technical disciplines as a core hierarchy that is self-contained. You can find several hints to that throughout the book and in several other places. So this question of, does this change also involve a change in how engineering knowledge is understood? This is not very forefront in the CDIO discussion. I think this is a problem, because that means that the abstraction of knowledge, the specific form of abstracting knowledge, that partly is a critical outlet for CDIO, isn't addressed. That means that there's a maintaining of what I would call a gap between engineering practice domains and the disciplines that is not addressed. There's no explicit discussion of new types of knowledge. I will exemplify the problem. Design projects seem to be some kind of an add-on. And here is where I come to the Ed Says part, Ed Crawley, the guru, together with Johan and others, on the CDIO program. He says, well, don't worry, it's not a big problem. You can start small steps and introduce some projects. 3 would be enough. And I would say, yes, this is of course a way of starting. But if you don't take the next step unless these projects challenge your whole program structure and the disciplines, the goals of the CDIO wouldn't be met. So it might be an easy start to accept this, well, don't worry point, but I think there's much more to it. So for instance, when we organize a project in the first semester on where we set the students out to do user studies and do some basic, simple constructions in relation to that, we need a course that integrates materials and structural mechanics and some mathematics in a focused way that supports these kind of design projects. And we couldn't find that in the classical teaching, though we had a number of teachers who were more than willing to go into this transformation process. I think this is an example that is important. In the other end of the program, we have a course on fluid mechanics that still is taught as fluid mechanics, abstracted model things. Doesn't mean anything really for the students, because everyone knows that turbulence and all these exceptions are what rules the world when we come to fluids and aerodynamics. So the real crucial thing for a design perspective is not part of that teaching. It forms a nice mathematical, mechanical, universal fluid mechanics of special cases. But it's so advanced that everyone almost breaks her or his neck on that course, even the teacher. But still, this is an example of a non-integration, while the other one is an example of integration. Communication and team skills as add-ons, this is also crucial. I think it doesn't work like that. We have to be very aware that it's about communicating in different settings. It's communicating within the technical student teams, it's communicating with the outside, the users, etc. So what is the challenges for CDIO? There's almost no focus on conceiving and operating in CDIO. So if we should make the acronym more correctly, a very small C, a very big PI, and a very little O. I think that's one of the challenges, because we can just, of course, take again what Ed says. Ed says, well, this is a framework, a context in which the engineering teaching goes on. Of course, that's an approach. I would say this is really crucial, because this is what engineering is about. Conceiving is important. And that challenges the course disciplines, because you can't, from within a discipline, understand what the conceiving phase does include. You have to have other types of approaches, methods, and knowledge to do that. And later this series of workshops, so this afternoon in Skills 2, I have a paper together with Klaus, a colleague of mine, on this conceiving phase. Of how can we work with conceiving? And on the other side, that also implies, I think I'm even less, so I'm finished now, more or less. It also challenges the competences. There's little focus on what constitutes engineering tasks and constitutes engineering projects, because that's also crucial. What is a good engineering project? And a lot of the engineering projects are about problem identification more than about problem solving. And this is not really very well addressed. And that again raises questions about the limitations of the very normative, the very instrumentalist, the very model-oriented type of knowledge. That is, of course, easier to teach. I know that, but this is about learning. There's a focus on educational form and not on content changes. I think this is what goes through the whole presentation here. We need to address the question of content. We need to address the question of what engineering is about and what the new challenges of engineering, which type of questions it raises. And therefore, team building, new insights, teaching staff is really crucial for this transformation process, because if the teaching staff doesn't change its perspective, if the teaching staff is bound to disciplinary boundaries, which of course is heavily supported by the demand for doing research in specialized disciplines. Everyone knows it's much easier to publish in a narrow discipline than it is to go outside. So we have to deal with that, and educational program reform has to deal with that. Thank you.
We have time for one or two questions. Does anyone want to start? Lena?
When research funding now is tend to go much towards large challenges and not so much about narrow, would that be something that would help changing the way we organize ourselves, and that would help changing the education?
I think so.
Because research will have to do things in different ways now, because funding is coming in different ways.
Yes.
Yeah.
I think that reflects also some of these challenges in society.
Yeah.
So in a way, it's not easy, but it's a way of doing this.
So could we use that to help making education better also?
Definitely. It's very typical that we, in our department, also for the more technical parts, we are much more going for the strategic programs than for the disciplinary classic kind of research programs. Because when we go there, they say, oh, well, this is too broad. Crossing boundaries. We might even take it up some social science aspects, and then it's out of question. We don't support social sciences. Would be the technical research council's answers in Denmark.
Okay, one more question while Lena is setting up.
I don't know if we have to figure out how to do this.
Okay, well,
Thank you.
Thank you, Ulrik.
Just announcement.
Thank you.